Hello, my name is Ryan Chazen. I am a student in Math 32, Section 1, and discussing Section 8D in the fall 2020 semester, and today I will be presenting on variance versus sample variance. So first, the question is, what is variance and what is sample variance? So variance is a measure of spread of the distribution of the random variable of the whole population. This is also known as population variance. Sample variance is the same as variance, but it is a sample of the whole population. So the sample variance is an unbiased estimator for the population variance, meaning the variance that you get for a sample population should be similar to the variance that you get for the population variance. So in simpler terms, variance tells you how spread out your data is. If your data is very spread out, your variance will be larger. And if your data is condensed, the variance will be smaller. So here are the two equations for population variance and sample variance. So first I'll go over the population variance. So it is the sum, sigma, of x minus, which is a data point, minus mu, which is the mean of the population. And then you square that, and then you divide that over the n, which is the total number of what you're looking for in the population. And then this is the sample variance, the bottom one, and that is sigma, which is the sum of x minus x bar. X is just, again, one of the data points, minus x bar, which is the sample average instead of the population average, mu here, squared over n minus 1. And n is the total number of the sample data points. So here I did an example. So I chose a sample set, meaning we're going to be using this sample variance. And the data points are 3, 2, 5, 7, and 8. So the first thing I did was find the average of the sample, x bar. And to do this, I just added up 3 plus 2 plus 5 plus 7 plus 8 and divided that by 5. And that gave me 25 over 5, or 5. And so that means x bar is 5 for this equation. Next, I did each data point x minus x bar. So I have 3 minus 5, which equals -2, and then so on and so forth for these other ones. And after that, I have over here, I squared those data points and then summed them. So I took this -2 that I got and squared it to get 4. And then I squared the rest of these. And that gave me 4, 9, 0, 4, and 9. And I added them all up and I got 26. And so the final part, I had to do 26, which is this top part of the equation, over n minus 1, so 5 minus 1, which is 26 over 4, or 6.5. Therefore, the answer to this problem of the sample variance of this data set is 6.5. So why is variance important in the real world? Variance is the measure of variability. So an example would be the stock market. So the stock market has a return on average of 7% per year. Now, this doesn't mean every single year that you're going to get 7% of the stock market. It's going to be 6.5%. It could be 10% one year. But the difference is a measure of variability. And that's what we use variance for. And a simpler example would be, let's say, like M&Ms. So if you manufacture M&Ms, there's an average of 85 M&Ms per unit. And some units could have more than 85, and some units could have less than 85. And that's another measure of variability. So here are my references that I have. And that will be all. Thank you for a great semester.